Hopefully this all works. Okay. So what I've got here is a magnet on a scale taped down. And I want to try and have this puppy as square as I possibly can, which is going to require a wee bit more work. There we go. Because what we want to record is how much weight an electric current produces against the magnet. So we don't want the magnet moving to one side or the other to avoid the electric current. Unfortunately, my U magnet is literally the letter U, as you can see. And I have two cameras running here, so one of the two will have audio. I'm not sure which is why I keep looking left or right to look at a camera. Okay. Let's see if I can. No, I'll leave it there. All right. So the next thing I have here is a piece of copper wire, and I want it about as straight as I can get it. And I'm going to place that here. The problem is I need the copper wire to produce a force onto the magnet versus the other way around. Otherwise, the copper wire is going to bend up like this. So here I am. I have my copper wire, and I want it to produce a force down on the magnet, but it's most likely going to bend up like this. So let's see if I can get that. Okay, I don't want that. Introducing hard card. Okay, so what I can do is I can put my hard card in the center here, and I can tape center of my magnet. I can tape it to my card, like so. Okay. So now that I know where it needs to go, I will just apply some tape liberally to hold it in place. Okay, finished product. Hopefully this works. Okay, so now I put this in the center like so, and this should, yeah, it's fitting in the center regardless. Okay, now what I need is some, the other problem that I'm having is I don't have a stand, both with the ability to lock it in place as well as produce a force that can pressure against the up force. All right, but we'll get back to that. So the next piece of the puzzle here is, let's see, and I don't think you are, okay, so I won't worry about that. All right, so the next piece of the puzzle here is batteries. I need power. And batteries are going to be the safest bet versus plugging it into the power supply. Last thing I want to do is blow a circuit. So, batteries heat up slower, they take more time, but what I need to find out is, do I plug the batteries in serial or do I plug them in parallel to get the appropriate amount of current that I want? So, I forget what the professor said we needed as far as amperes was concerned, but I think it was something on the order of 5 amperes or 15 or 30, but we were using 5 volts. And these are 9-volt batteries, so what I need to do is figure out how many 9-volt batteries do I need in series or parallel to get the appropriate amount of amperes. Ta-da. Okay. So let me pull up my other phone here. And we'll do a quick Google search. Hello? Okay. Batteries in series. Battery series versus parallel. Okay. In series, adds voltage potential to drive the total. Parallel connection contains higher capacity, total amperage. Okay, so I want amperage. I want to hook them up in parallel. Well, I need some more wire because I have to hook the batteries up like this to get the appropriate amperage. So we will continue. Okay, here I have my batteries all lined up. So I'm going to set this aside for a second. Bring my batteries to center here. And what I want to do, I need another piece of wire, so I'll be back in a minute with that, is I want to hook this piece of wire to all the ends of my battery. And one of the ways that I can do that, I wish I had battery caps, but I can do this by slowly feeding it through this, like so. If I grab it with my pliers here, I can pull it through. And I just keep feeding batteries on like that. It's going to be a little bit harder when we get to this one. That's why I like battery caps. There aren't enough available at the moment. So we will try to make do with what we got. And I'll be back. Okay, so I've succeeded at threading my wire through the first half, all the, I don't know, the positive or the negative sides, I can't tell. And yeah, negative sides. It's marked on the battery itself. Okay. So, first half done. Now the second half is I need another piece of wire, which I'm going to go get, and thread that through, and then I'll return. So one of the things I should mention is I'm a former network administrator. As such, I always have little bits of network cable hanging around. Nice thing about that is, it makes for great cable from kits like this. So, here's my cable. I've got lots of tools that are necessary for this particular little project as well, that aren't necessarily network related, but hey. So let's pause. I'm going to put this cable on and we'll go from there. Okay, so I'm threading the cable on. And mind you, it'd be nicer with little snaps. It'd be much easier. But as I said, don't have them, can't find them. Radio Shack doesn't exist anymore. So what I'm doing is I'm winding the copper wire around each one of the positive diodes. Now, as you can see, I've got not enough. I'm probably going to cut it up to about there. So I'm going to do that. Start over, and I'll be back. Okay, so I'm wiring it down, but I'm finding that the wire is popping up every single time I put the wire on. And I accidentally cut my wire. So, we will make life do by taping. Oops, I probably need a little bit longer piece of tape. But by taping the wires down onto the pads. Okay, so dump, press it down. And press it down. And do a little cleanup here. Okay, guess I can do the next couple here. Oops. getting ahead of myself. Doesn't want to stay on. There we go. There we go. And we'll take these two down, and we should be good to go. And before I tape this last one down, I want to do this by tying them together. There we go. And tie that down. Okay. Now, if I've done everything correctly, and I cut this off like so, without breaking the copper. There we go. All right. Let's see here. Okay. All right. So if I've done my job correctly, I take my amp meter here and I plug it in. What I want to do, first of all, is set this to volts. So I'm going to set it to 150 DC volts, which shouldn't register anything, to be perfectly honest. So my negative side goes in the negative, my positive goes in the positive. You always start high and work your way down. So my negative side is this, and my positive side is this. Ooh. Houston, we have a problem. Because I am registering 2.5 volts. And I lost my copper wire. No. Okay. So let me peel this back here. And what I will do instead, there we go. So I will try and thread this copper wire around this. Yes. And apply tape back over it. Yes. Ah! And of course I can't pull on it. Okay, that should allow me to pull on it now. All right, let's check this out again. So negative to negative, and positive to positive. And sure enough, I've got roughly 2.5. And this is set for 150 DC volts. Let's see what we get on the 15-volt setting. There. And we plug it. I thought we were supposed to get current. Okay, so what are we getting current-wise? Because if I just took all that time to do this, and I'm not getting what I need for current, and we're plugged for current. So we're definitely over 15 volts. Either that or my meter is off. So at 115 volts, 150 volts, we're getting 2.5. Yep. All right. Lots of current. That's what I need. I'm not sure what my voltage is at the moment. We'll have to figure that out in a bit. Okay. Now, let's see what happens with my wire when I plug it in. Okay, so this is negative, that's positive. Let's go ahead and bend this like so. It isn't going to balance at the moment, that's fine. I don't need it to balance. But what I do want it to do, let's see, let me grab some books. How about Counting Made Easy? Understanding by design. Okay. So I've got something that will at least hold. Maybe I need a little bit more. And I got to make sure that these aren't affecting my scale. Okay. Whoops. Wow. So that's a lot of current flying through there. It caused some smoke. Ladies and gentlemen, we have smoke. All right, so I need a little bit more, a couple more books. Isn't physics all about the book of questions? Okay. Okay. All right. So that gets my little wire running through here off. Looks like we need to make my bend a little bit longer. Okay. Trying not to burn my books just in case the amount of current going through this puppy is really, really, really strong. All right, so the current should push the magnet into the scale. And if that works, nope, all I'm getting is a lot of heat. A lot of current, a lot of heat. But nothing from the scale. Sure. One last time. 1, 2, 3, 4, 5. Nada. Okay. Well, that's about an hour's worth of time, I think, or 20 minutes. So, tried the experiment. I guess I'm going to have to use the experimental data that the professor gave. Good luck, guys.